Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NTA exam, PhD exam, SET exam, TIFR, Jest, IIT-Jam and other exams related to physical science. Okay, so this is the lecture number 19 of quantum mechanics, in which we are going to discuss angular momentum. Okay, and also I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures, which are going to help you to crack the exams related to physical science. Okay, well, so I'm going to start now. This is 19th lecture of quantum mechanics, and I'm going to discuss angular momentum today. Okay, so angular momentum. Angular momentum. Okay, so angular momentum, we know that is L equal to r cross p. P is the linear momentum, r is the position vector, right? Or we can write I j k uh, x y z and px py pz, right? Where do you know r equal to x I cap plus y j cap plus z k cap, and equal to px I cap plus py j cap plus pz k cap, right? Very simple. So from here we can open it and we can get value of lx, ly and lz. Okay, so value of lx is going to be lx is y pz minus z py. Okay, y pz minus z py, and ly is going to be z px minus x pz. Okay, z px minus x pz, and z is going to be xpy minus ypx. Okay, xpy minus ypx. These are the values. If you open it, and we'll get the value of lx, ly and lz, because l equal to lx I cap plus ly j cap plus lz. These are basic things, right? Okay, l lz k cap. Meanwhile, just let me check whether I'm audible or not. My channel yet? Yes, I'm audible. So I'll proceed further now. Okay, so I'll write some properties of angular momentum. Okay, so this is going to be this is like lx, li, lj. This is the general form. Okay, lj is going to be I h cut Levisita delta Levisita symbol I j k and l k cap. Okay, this is general symbol. So I'll write here, for example, like lx ly. Okay, lx ly. You can easily memorize this as well. Like this is x. After x there is y and z. Okay, y, after y z and x. Similarly z, then x and y. Okay, so here uh, that is lx ly. Lx ly value is I h cut lx ly, and what is after that? This is lz. Okay, there would be negative sign if it is not in cyclic order. X y, this is in cyclic order, right? If it would be x Ly Lx, then this would be minus iota z. Okay, for example, like Ly, these are very important property, right? You need to note down. You will get questions from it. So Ly Lx, okay, we have just reversed the order, and in that case it is going to be minus I h cut Lx Ly, that is Lz, okay, because it is not in cyclic order. That is why this is the general form. Next property, L square L, okay, if that is the one, then this is going to be 0. For example, L square Lx, this will be 0. L square Lz, this commutation is going to be 0, and L square Ly, this is going to be 0. Very important property, guys, okay. Next properties, so Lz, right, this is not in cyclic order, and this is going to be minus iota h cut Lx Lz, which is remaining Ly, okay, simple. So we have 3 Lx Ly Lz. If Lx and Lz here, then the remaining one will be here, okay. And if it is in cyclic order, then it will be plus iota h cut. If it is in if it isn't cyclic order, then the minus sign will be there, okay. Now next is this, as I'll prove this, okay. Now this one, Ly square Lx, okay. We have to find the commutation of Ly square Lx, okay. So how we can find it? I have already explained commutation properties, right, in quantum mechanics in my previous lectures. You can check it. This is the 19th lecture of the quantum mechanics, okay. So we can write it, there's a commutation property, okay. We can write it Ly into Ly Lx, okay, in this way. Then we will open it. We know how to open it. This is going to be Ly Lx, okay, and okay, and then this is going to be plus plus Ly Lx, and outside Ly, okay, this is Ly. So Ly Lx value we will find, okay. Yeah, we have done, this is not x, this is Lx, this is Lx, right. So this is going to be Ly, this one Ly Lx, right, and then Ly Lx outside this, okay. So Lx Ly we know, Lx Ly I have already written the property. So I h cut yx, it is in reverse order, right, not cyclic order. So I h cut Lz, okay, plus Ly Lx, this is also not in cyclic order. I minus iota h cut Lz Ly, right. So here we can take minus iota h cut common. So it is going to be Ly Ly Lz plus Lz Ly, okay, Ly Lz plus Lz Ly, okay, Ly Lz plus Lz Ly, okay. In similar way, we can find this one Lz square Lx, okay, this commutation, and this is simply because this here you can see this is not in cyclic order, that's why we have this order minus iota h cut Ly Lz Lz Ly. In similar way, we can write here iota h cut because it is in cyclic order, and this is going to be LZ, LY, LZ, LY plus LY, LZ. Okay. Next property is this I have already written, that is Lx square Lx, right? This value is 0. How this is 0? I'm going to solve it. That is, I can write Lx into Lx and Lx, right? So this is going to be Lx by commutation property, which I have already explained like this. I'll write here ABC, ABC, commutation ABC, right? This is equal to ABC plus AC outside, right? This is the property ABC plus AC outside. Okay, so here this is Lx, Lx, Lx plus going to be Lx, Lx outside Lx, and we know if there is same term in the commutation that is 0, right? We know, right? Commutation commutation of A is 0, right? Similar term. So Lx, Lx is also 0. So this is 0 plus 0, that is 0. Okay. So this is 0. So this means Lx, Ly, sorry, my apology. This Lx, Lx equal to Lz, Lz equal to Ly, Ly. Their commutation is 0. Okay. Well, now I'll write raising operator and lowering operator. Okay. Raising operator. So raising operator is this one. That is denoted by L plus. Okay. L plus, and that is equal to Lx plus I Ly. Okay. Lowering operator. Lowering operator. Lowering operator. Lowering operator. We can write like this. Lowering operator is going to be L minus. Okay. And that is Lx minus I Ly. Okay. Lx minus I Ly. Next. I'll solve the question. So there you need to this commutation you need to solve, that is L square L plus minus. Okay, L plus minus we know, right? So this we can solve it. We'll write L square, and this L plus minus is L plus is Lx plus minus L iota Ly, right? I'm writing together. Okay, for L plus is Lx plus Ly, and for L minus is Lx minus Ly, right? So we can write it by commutation property. This is going to be L square Lx plus minus iota will come outside. This is going to be iota L square Ly, right? And these values are 0. I have already explained. L square Lx or L square Ly or L square Lz, that is 0, plus minus 0, that is 0. I have already written here. This one, L square Lx these values, right? L square Lx, L square Lz, L square Ly, 0. Okay. Well, so this is the one. Next is, these are very simple properties, commutation properties we are solving. Okay. Lx, L minus, okay, Lx L minus. So this is going to be Lx L minus, we can solve it. So this is Lx commutation, and this L minus is going to be Lx minus iota Ly, right? So we'll write it Lx commutation of Lx with Lx, and then minus iota will take outside, and this is commutation of Lx with Ly, okay? And commutation of Lx with uh, Lx is going to be 0 minus iota, this is Lx Ly, right, in cyclic order, so iota h cut Lz. So this is going to be minus iota, that is minus iota square. Minus iota square is minus 1. This is going to be plus, right? So h cut Lz. This value is h cut Lz. Okay. Next. Next is, so these are the commutation property. I'm solving. Okay. This is very important chapter, guys. So many questions you will get in your examination. Next is Lx L plus. Okay. Lx L plus. So this is going to be like simply Lx and L plus, we can write Lx plus iota Ly, right? So this is going to be again commutation property Lx commutation of Lx plus iota commutation of Ly, right? So this is going to be 0 plus iota, and this value is in Lx Ly means Lz, iota h cut Lz, okay? So because it's in cyclic order, so iota h cut Lz, and iota square is minus 1. So minus h cut Lz, minus h cut Lz is the answer, okay? Next is Ly L plus, okay? This is going to be Ly L plus value, we know this is uh, Lx plus iota Ly, okay? So this is going to be Ly Lx commutation plus iota Ly Ly. This value is going to be 0, this value yx, it is in reverse order, right? So this is going to be minus iota h cut Lz. This is 0, okay? So answer is minus iota h cut Lz. These are the property, guys, you need to note down and practice it, okay? And then if these formulas or these uh, formulas are going to be in your fingertips, okay? Next is one L minus L plus, okay? So next is Ly Lz L plus, okay? Lz L plus, its commutation we need to find. So this is going to be simple Lz Lx plus iota Ly, right? And then will be commutation property. So Lx L, my apologies. So this is Lz Lx commutation plus iota outside Lz Ly, right? So this is going to be Lz Lx, right? It's in cyclic order, means iota h cut, which is not there, Ly, right? Similarly here, iota Lz Ly, this is not in cyclic order, guys. Okay, so Lz Ly, so minus iota h cut Lx. Okay, so this is going to be iota h cut Lz, and this is iota minus iota square minus 1, right? Plus h cut Lx, h cut Lx, okay? Iota Ly, iota h cut Ly plus h cut Lx, okay? Next is LZ L minus. Okay, we need to solve it. Simple. LZ will remain as it is, and L minus value is Lx minus iota Ly, right? We'll use commutation property, so it is going to be Lz Lx, right, minus iota outside, and this Lz and Ly. Okay, so these values are Lz, Lx, Zx, right? So iota h cut Ly minus iota Lz, Ly in reverse order, so it is not in cyclic order. So Lz, Ly is going to be minus iota h cut Lx. Okay, so this value is going to be iota h cut Ly, and this minus minus plus iota square is minus 1, so minus h cut Lz. Okay, so h cut Ly minus h cut Lx. Okay, next property. This is L plus L. This is going to be L plus L means Lx plus iota Ly comma L, right? So this is going to be Lx L plus iota outside Ly L, Ly L. Okay, so this is going to be Lx L means this Lx with L, this value is 0. Okay, Ly is well, this value is also 0, so this is 0. So Lx L or Ly L or Lz L, these values are going to be 0. Okay, you need to note down. Okay, I can write it up for you. Lx L equal to Ly L equal to Lz L commutation. Okay, these values are 0. Next one. So here we know that this one, right? I've already explained that uncertainty principle. For here we can use like this delta Lx for delta Lx and for delta Ly. Okay, delta Lx for delta Ly, this is going to be this for general formula we know, right? Mod of average value of commutation of Lx Ly upon 2, right? So this we know. So value of Lx Ly is iota h cut. So this is going to be mod of iota h cut Lz upon 2, right? And this value is going to be that this is delta Lx delta Ly is going to be equal to this one. H cut by 2 will take outside, and h cut by 2, and this is Lz, expectation value of Lz. Okay, so it means we can say this value is delta Lx into delta Ly is equal to h cut by 2 average expectation value of Lz, right? So this is the value. Okay, this implies we cannot measure Lx and Ly accurately simultaneously. Okay, so for simultaneously we cannot accurately measure Lx and Ly. Okay, because this is the value. Now we'll take for this, for example, for next we'll take delta L square delta Lz will take it. Okay, and this is going to be h cut by 2, we can write like this similar way, mod of expectation mod of average of commutation of L square Lz upon 2, right? So here the commutation of L square Lz is 0, we know. I have already explained earlier, right? So commutation of L square Lz, okay, or L square Ly, or L square Lx, this is 0, right? So it means this value is going to be 0, right? So delta L square into delta Lz is 0. So this means L square and Lz can be measured because their commutation, they commute with each other, right? So can be measured simultaneously 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 with perfect accuracy, okay, with perfect accuracy. Okay, so L square and Lz can be measured simultaneously with perfect accuracy because their commutation is 0. They commute with each other, right? Okay, so this is about uncertainty principle uh, for for these L square and Lz, okay, angular momentum. Okay, next point. These are very important points I'm writing so that you can easily solve questions, okay. So value of L square, okay, value of L square is value of L square is h cut square into L plus 1, okay, this is the value h cut square uh, L into L plus 1, this is the value of L square, and value of Lz is value of just L is h cut root L into L plus 1, okay, and value of Lz, these we know, but you need to know. So value of Lz is, we have solved many questions using these formula, right? So value of Lz is m h cut, okay, these are ml values, right, or we can say ml h cut, okay. So like for L equal to 1, value of ml are 0, 1 and minus 1, okay, that is minus L2 plus L, right? These are the value of ml. Okay, so now we can write like this. So L square, if you operate L square with, very important, L square with state Lm, okay, Lm is the state, okay, so this is going to be uh, h cut square L into L plus 1 Lm, okay, important thing. Similarly, if you operate Lz with Lm, this is going to be ml h cut or m h cut, we can say ml h cut, and this is going to be L comma m, okay, with eigenstate. This would, if you operate L square with this state and Lz with this state, the state is not going to get changed, right? Okay, state will remain same. Now next is if we operate L plus, okay, L plus with Lm, here this state is going to be changed, okay, so this value is going to be L plus, so you need to note down, okay, this is going to be L into L plus 1 minus m into m plus 1, okay, h cut is here, okay, h cut into L into h cut into root L into L plus 1 minus m into m plus 1, and the state is going to be this one, L m plus 1, okay, so in m it will change. There would be change in m by 1. Okay, this is m, so this is going to be m plus 1, the increase of 1 in the m. Okay, similarly L minus operator, that is ladder operator, right? Lm, here the value of this is going to be h cut root L into L plus 1 minus m into m minus 1. This is minus, this is minus 1. Okay, and the state is going to be L comma m minus 1. So decrease by 1. Okay, m will get decreased by 1. Okay, so this is 1. Okay, h cut L into L plus 1. So L plus means the m will be m into m plus 1. Okay, and L minus means m into m minus 1. Okay, and there would be changes. Okay, so if plus 1 change, so m will get increased by 1, and here minus, so m will get decreased by minus by 1. Okay, these are the important values, L plus and L minus operators. Okay, next, matrix representation, very important, guys. Okay, how to represent these operators in matrix. Okay, so matrix representation, matrix matrix representation matrix representation. So L square, how to uh, do L square. Okay, so L square is going to be this one, 1 L square 1 with 1 L square 2 with 1 L square 3 with 2 L square 1 with 2 L square 2 with 2 with 2 L square 3. Here 3 cross matrix, 3 L square 1 and 3 L square 2, 3 L square 3. Okay, like this will represent. I will explain it, then it will clear your doubt. Okay, so okay, so now since for L equal to 1, the value of ml going to be 0, 1 and minus 1, right? So we are so here we have represented, you know, 1 2 3, 1 2 3, right? So I'll tell you what is 1, what is 2, what is 3. So here 1 is, so you need to understand this. Okay, lm, these are the state. Okay, lm, so lm equal to this, m equal to 1, so I can write similarly, m equal to 1 0 and minus 1. Okay, so first we'll take m equal to 1, l equal to 1 and m equal to 1. Okay, this is going to be 1 1. Okay, 1 1, this stage is denoted by 1. Okay, and similarly this is going to be, second one is 1 0, l equal to 1 and m equal to 0, 1 comma 0, this state is denoted by 2. Okay, and similarly 1 minus 1, 1 minus 1. Okay, in this state in the form of lm, so this is going to be denoted by 3. Okay, so this is 1 1 minus 1 is 3. Okay, so these are the states. So this means one state means 1 1, 2 state means 1 0, state 3 means 1 minus 1. Okay, so now we can put value here instead of 1, instead of 2, instead of 3. So this is going to be the matrix of L square is going to be, and also I need to write this one as well. Okay, just wait. Yes, like this one. Okay, if L dash M dash, okay, these are the state with L square Lm. Okay, if these are the state, this value is going to be, L into L plus 1 h cut square. Okay, and this is h cut square. This value is going to be this one, L dash M dash into Ln. This value is going to be L into L plus 1 h cut square. Okay, and this is Kronecker delta L dash L and Kronecker delta M dash M. Okay, so this value is going to be we know Kronecker delta, right? So L dash Kronecker delta L dash L will be 1 if L equal to L dash, right? L equal to L dash. Similarly, Kronecker delta M dash M is going to be 1 if M dash equal to M, and this is going to be 0 if M dash not equal to 0, and also this is going to be 0 if L dash not equal to L. Okay, so we know about Kronecker. So this is this you need to know it. Okay, so L square. So will operate with L square, and this is going to be this. Okay, so if L dash M dash L dash M dash and Lm, right? So this value is going to be Kronecker delta L dash L and M dash M. So if L dash equal to L, then this will be 1. If M dash equal to M, then this value will be 1. Otherwise 0. Okay. Now we will write the matrix representation of L. So the 1 into 1, right? This one. 1 into 1, you know, one state is, I have already written, one state is 1 1. Okay. And state 2 is 1 0. This one. 1 0, and state 3 is 1 minus 1. Okay, 1 minus 1. So now in place of these 1 1 and 1 or 2 state, will write the value. Okay, and then we'll evaluate. So this is going to be 1 1 L square 1 1. Okay, so this matrix representation, and this is going to be 1 1 L square 1 2. 2 state is 1 comma 0. Similarly, 1 1 L square 1 minus 1, right? How this one? 2 value is 1 0 and 3 value is 1 minus 1 minus 1, right? And similarly, this is going to be 2 2 is 1 0, 2 state is 1 0, right? Here 2 is 1 0 and 3 is 1 minus 1, 1 is 1 1, right? So 1 0 to L square 1 1, right? So 1 1. Similarly, 1 0 L square 10 L square, 10 L square, and this is 10, right? Similarly, 10 L square, L square, 1, 1. This is 1 minus 1, right? 3. Similarly, 1, this is like this, going to be 1 minus 1 L square, 1, 1. Similarly, 1 minus 1 L square, 1, 0. And this is 1 minus 1 L square, 1 minus 1. Okay. So these are the values. Okay. So you can see here also I have told you this one. Okay. So L square Lm is value going to be this will be the eigenvalue, and state is there is no change in state. Okay, for L square and Lz. So now we'll put the value. So we know, right? So value of L square in matrix representation is going to be simple, which is these are the equal value, right? L square, value of L square, L into L plus 1, right? L value is 1. 1 we are operating with it. This is L, this is M. Okay. So L square into L. So this is going to be L into L plus 1. 1 into 1 plus 1 means 2 h cut square, right? 2 h cut square. These values are going to be 0 because these are different states, right? L square will take outside, then this is this state is going to be 1, 1, 0, 1. 1, 1, 1 into 1, 0, right? This value is 1, 0 with this one, right? Chronicle delta by this, right? So these values are 0, 0, and similarly here this is going to be 0, and for this value is 0, right? 2h cut, 0, 0, 0, 2h cut, right? Because this value will give 1, other values are giving 0. So we can take 2h cut square common. So it is going to be identity matrix 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay. So this is the matrix representation of L square. Okay. Now we'll find for Lz. Very important, guys. Okay. For Lz. So for Lz, I will write this first. Okay. For Lz, this is going to be so L dash M dash. Okay. And this is this is L Lz. Okay. And this is going to be Lm. So this is going to be M h cut. M means ml. Okay. M h cut, and this will be M h cut delta L dash L and delta M dash M. Chronica delta, right? So chronica delta means we know it, right? We know it. So this is if this value is 1 if L dash equal to L, and this value is 1 if M dash equal to M, right? So this is the first one, right? So these if these should be equal, then this value will be M h cut, else value is going to be 0. Similarly, in case of this one, L dash comma M dash, and there is a ladder operator plus, that is raising operator. Okay, so that is L M dash. Okay, if this is the one, so it's a ladder of this is the raising operator, and we know that the value is h cut square root L into L plus 1. Okay, root L into L plus 1 minus M into M plus 1, and this is going to be chronicle delta, chronica delta L dash L and chronica delta M dash M. And we know that I have already written here, right? This one. If L dash L equal to 0, then this value is 1. If L dash equal to L, then this value is 1. If M dash equal to M, then this value is 1, else 0. Okay, we know about Kronecker delta. Okay, so this, and similarly for L dash, M dash, L minus, that is lowering operator LM. Okay, so this value is going to be h cut root L into L plus 1 minus M into M minus 1. Okay, minus M into M minus 1. So this is going to be delta, Kronecker delta L dash L and Kronecker delta M dash M. Okay, so this is the value, and we know about it, right? Using those, will represent Lz and L plus and L minus. Okay, so for Lz now, Lz matrix representation is going to be this one, 1 1 Lz 1 1. Okay, similarly 1 1, so this is first state, right? 1 1 Lz 1 0 second state, right? And similarly 1 1 Lz third state, right? So this is 1 minus 1, right? Similarly we can write 1 1 Lz, this is 1 0, guys. Okay, 1 0 1 0 Lz 1 1 1 0 Lz 1 0, and similarly 1 0 Lz 1 minus 1. So again this is 1 minus 1 Lz 1 1 1 minus 1 Lz 1 0 1 minus 1 Lz 1 minus 1, right? So here these are the equal values. Lz will give, right? Lz, and this will be the equal, and these are the equal value, and these are going to be 0 because according to this Kronecker delta rule, right? So Lz is going to be, this is going to be, here we can see this one, okay? So Lz value mh cut, right? M is 1, L is 1, right? Mh cut square, right? So this is going to be mh cut square, right? So this is 1, this is 1, so mh cut square. So this is 1. Have you made any mistake? Let me check. Okay. Yes. So now these are values are going to mh cut, right? So mh cut means h cut 0 0. This is going to be 0. This is h cut 0 0 0. This is h cut because this value is mh cut, and this value is by Kronecker delta. This value is 1, right? Other values are going to be 0. So this is going to be h cut 0 0 0 h cut 0 and 0 0 h cut. Okay. So this is going to here, right? Okay, so this is going to be 0, guys. This is going to be 0. Why? Because here you can see 0 0, right? M state is 0, so M h cut 0 into h cut 0, right? So this is going to be Lz divided. So we have represented Lz into matrix, right? For Lz we can write like this. So h cut we can take common, so this is going to be 1 0 0 0 0 0 0 0 1. So this is the matrix representation of Lz. Okay, this is minus 1. Why minus 1? Because this is minus m, right? Minus m h cut, so minus 1 into h cut, that is minus h cut. Okay, so this is minus h cut. Okay, this is about this. Now we'll represent this one, L plus and L minus. This is also very important. Okay, so I would request you practice it, guys. Okay, if you practice 2-3 times, then you can easily learn it. Okay. Okay. Next is L plus. L plus also similar thing, right? So for this is going to be same thing. This is going to be this one. 1 1 1 comma 1 L plus 1 comma 1 L plus, and this is going to be this one 1 1 and 1 1 L plus 1 0 1 1 L minus 1 minus 1. Okay, similarly 1 0 L plus 1 1 1 0 L plus 1 1 0. Okay, similarly 1 0, and this is 1 0 L plus, these are L plus. Okay, L plus 1 0 L plus 1 minus 1, and this is 1 minus 1 L plus 1 1 1 minus 1 L plus 1 0 and 1 minus 1 L plus 1 minus 1. Okay, so this is the L plus. Now we need to understand this. L plus means we know this value, right? That is root h cut root L into L plus 1 minus m plus 1. Okay, and then this state is going to be this is L plus 1 L plus Lm. L plus Lm is going to be this one. L this m plus 1 into L comma m plus 1. 1 will be this, right? So this we are going to solve it now. Okay, so L plus. So here we'll check these values. Okay, this here we check this. So we need 1 1 1 1, right? So this is not possible because this is going to 1 plus 1 2. So this is not correct. Here 1 and 0 plus 1. Okay, so this is going to give value 2, right? 0 plus 1. So this value is going to be 0. This value is 0 plus 1. Okay, so the state will be 1 0. So m is 1 0, right? M plus 1 0 plus 1 1. Okay, so L. So this is m equal to 0 and L equal to 1, right? So L 1 means root L square plus root 1 square plus root 2 h cut, right? So this is going to be root 2 h cut. Okay, and this is 0. Similarly here these two are going to be 0. This value, this is 0, right? This state is 0 1 0. So this is going to be m is plus, right? Minus m plus 1 minus 1 plus 1, right? This is 0. 0 means 0 means this is m is minus 1 and minus 1. So root if we put the value of minus 1 m and L value 1 into root L into L plus 1 minus m into m minus 1 h cut, this value is going to give root 2 h cut. Okay, you can check it, and other values are going to be 0, guys. Okay, so this is the value, or we can write root 2 h cut, we can take common. So this is going to be 0 1 0 0 0 1 or 0 0 0. Okay, similarly we'll find L minus, and that value is going to be, I'm going to write directly so you can do like this. Okay, this value is going to be 0 0 0 root 2 h cut 0, 0, and 0 root 2 h cut 0. Okay, this one. Or we can take root 2 h cut common, and this is going to be 0, 0, 0, 1, 0, 0, 0, 1, 0. Okay, this one, guys. So these are the values of L plus L minus, right? Next point. So quickly we can write L. This is Lx and Ly. Lx is going to be, because we know there's a formula, right? So there's a formula we have. This is L plus equal to Lx plus Li Ly, right? Li Ly, and similarly we have L minus equal to Lx minus I Ly, right? From here we can easily find Lx. L plus and L minus value we have. So L plus Lx we can represent it. So this value is going to be uh, h cut by root 2, h cut by root 2, h cut by root 2, and this is going to be uh, 0, 1, 0, 1, 0, 0, 0, 1, 0, right? This is the value of Lx, and similarly value of Ly is going to be uh, minus iota h cut root 2, h cut root 2, and this value is going to be 0, 1, 0, minus 1, 0, minus 1, and 0, minus 1, 0. Okay, these are the values of this. Okay, a matrix representation of those operators. Okay, so now we'll write this one. Spin angular operators, spin angular operators, spin angular operators, right? This similar as orbital operator. So the properties of commutation I'm going to write. So Sx, Sy, this value is going to be iota h cut Sz. Okay, and general form we can write it also. So this is going to be Si, Sj. If they are cyclic, then I h cut Sz. If they are not cyclic, then minus sign will be there. This is going to be iota h cut Lebesita delta ijk cyclic order should be, and this is sk. Okay, and the value of s square and s is going to be 0. Value of s square and sz, this commutation is going to be 0. Okay, and in similar way I can write it very simple. So s square, s, there are two states, s into ms. Okay, there lm, right? So here s into ms, s into ms is going to be h cut square s into s plus 1, and this is going to s ms. Okay, and similarly sz, s ms, this value is going to be ms h cut, and value is s ms. Okay, these are the points. Next, similarly s plus is going to be s ms. This is going to be simple h root s into s plus 1, s into s plus 1 minus ms into ms plus 1 for plus. Okay, ms plus 1, and state is going to be s and ms plus 1, right? Similar way like l plus, and similarly for s minus is going to be sms. This is going to be h cut root s into s plus 1 minus ms minus 1 s ms minus 1 decrease, right? And also the average value of sx, and average value of S plus and average value of SY, average value of this S plus and SY, okay, average value of S minus, these values are 0, okay. Next point, this one, average value of SZ, average value of SZ is MS H cut, okay, and similarly, average value of, just let me check, average value of average value of S square is going to be H cut square S into S plus 1, okay. Well, this about, and here we can also write represent this, and here I would tell you S value of S is 2 and value of MS is that is 1 by 2 and comma minus 1 by 2, okay. So these are value of S, for value S equal to half, MS value as half and minus half, okay. So here the state 1 is, in case of this similar way, right, state 1 is this one, uh, like ML, right. So this is uh, SMS, right. So S is half, MS is half, and state 2 is going to be this one, half comma minus half. This is state 2, okay. So we'll represent the matrix. So this is going to be S square, and this is going to be uh, half half S square, half half, okay, and then half half S square, half minus half. Similarly here, uh, half minus half S square, half minus half, and is half plus half, and here half minus half S square equal to half minus half, right. And we put the value, and because value of this S into S square, H square, this is going to be H cut square. S value is 1 by 2 into 1 by 2 plus 1, okay. So this value is going to be 3 H cut square by 4. So this value is going to be in matrix form. Matrix value of H cut square is going to be, this value is going to be 3 H cut by 3 by, I'll write in next page. So matrix representation of S square, these are very simple, guys, okay. So 3 H cut square by 2, 0 and 0, 3 H cut square by 4, this is 4, okay. These are the value, or we can take 3 H cut square upon 4 common, so this is going to be 1 0 0 1, okay. 3 H cut by 4. Well, so this is about this. Next is, so similarly we can get SZ value, okay. SZ value we can get, so SZ value in matrix form is 1 0 0 minus 1, okay, and H cut by 2. And similarly value of S minus is going to be, you can do by your own as well, 0 0 H cut 0, okay, and S plus is going to be S plus is 0, H cut 0 0, okay, and Sy, and you can write also these operators, and these are the thing, and Sx you can write Sx is going to be H cut by 2 uh, 0 1 1 0, okay, and similarly you can write Sy H cut by 2 0 minus iota 0, okay. So these are the this, right? The matrix representation of spin operator, okay. Now polymatrices, guys. Polymatrices, time is already over. Let me just quickly finish this. Polymatrices, very important, okay. Sigma x, this value is, we know it, 0 1 1 0, okay, and sigma y value is 0 minus iota 0, sorry, iota 0, iota 0, okay, and sigma z equal to 1 0 0 minus 1, okay. And there are some properties of polymatrices, right? Like sigma x dagger is sigma x, okay, and similarly sigma y dagger is sigma y, and sigma z dagger is sigma z, okay, and trace, and their determinant is -1, guys, okay. So determinant of sigma x, sigma y, sigma z equal to -1, okay, and also because this is -1, and so this says that polymatrices are Hermitian matrices, okay. Polymatrices are Hermitian matrices, okay, and their trace is 0, okay. Their trace, if you check trace of them, this is 0, okay. And what is the more important property is this one, commutation of sigma x comma sigma y, okay. This is going to be 2i sigma x sigma y means sigma z, okay. These are also cyclic. If it is in reverse order and not in cyclic order, then there would be minus sign. Similarly, we can write uh, commutation of sigma y sigma x, this is going to be minus iota sigma z, okay. And this one very important thing, anti-commutation of sigma x sigma y, okay, and that is 0, guys. Sigma x sigma y equal to 0, okay, and similarly sigma z sigma y, and also anti-commutation of same sigma x sigma x, okay, or sigma y sigma y, this is going to be 2 iota, and this is very important property. We can sx sz sx sy sz, we can write it, so right, we know the value of this. This is going to be h cut cube upon 2, right, h cut cube upon 8, right, and this is going to be sigma x sigma y sigma z, okay. Anything remaining? This one very important, sigma x into sigma y is iota sigma z, guys, okay. If it is in yeah, this is 1, and similarly sigma y into sigma z equal to iota sigma x, okay. And one most important property, you will get question from here, This is very important property. E to the power iota sigma dot n cap theta. This is I cos theta plus iota sigma dot n cap sin theta. This is very important property. By using this property, there are many questions we can solve it, and these questions are asked in NET and other exams. Okay. Well, guys, before ending the so this is about the angular momentum. Okay, and we'll solve questions as well. So, guys, before ending the class, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures, which are going to help you to crack the examinations related to physical science. Okay, guys, thank you so much. Bye now.